Hello, welcome to STR8CHEM. So now we're gonna learn how to draw the most plausible Lewis structure. And for this session, we're gonna use the example of an F3, and we're gonna look at the steps on how to draw the most plausible Lewis structure for an F3. So to start, we need to do step number 1, in which you need to count the total number of valence electrons involved in the formations of the Lewis structure. Okay, we know that in the given molecule just now, it involves one N atom, and it involves 3 F atoms, and we need to know the number of valence electrons for both. Okay, so to do that, there are 2 steps. There are 2 ways of doing that. Either you can memorize the position of the atoms on the periodic table. For example, I do remember that nitrogen is situated on group 15 in the periodic table. Therefore, the valence electron for nitrogen would be 5. If you do not memorize that one, what you can do is you can look at the given table of the list of elements, and you know that nitrogen has the proton number of 7. Therefore, the SPDF notation would be 1, 2, 3, 4, 5, 6, 7 would be like this. And when you look here, this is the outermost shell. Okay, so the outermost shell, hence those are the valence electrons, which is 5 valence electron. Okay, so there are 2 ways on how you can identify the number of valence electrons. Number 1, you can either memorize the position of the atoms or the elements on the periodic table, or you can do this method over here, which is, in my opinion, it's much better because you don't have to force your brain to memorize a lot of things. Okay, this information is given to you in exams. You just need to look in the table given to you, and then you can work out the SPDF notation to know what is the number of valence electrons involved. Okay, so that is how you're going to find out the number of valence electrons. So going back to here, fluorine, in the periodic table, fluorine is situated in group 17. Therefore, the valence electron is 7. And coming back to here, you can see that 1 nitrogen atom is involved. Therefore, 5 valence electrons. And then you have 3 fluorine, so times 3, and you have 21. So in total, you have 26 valence electrons. So when you do this, you will be given 1 mark in exams. When you identify the total number of valence electrons involved in the formation or in the construction of the most plausible Lewis structure. Moving on to step 2, you have to draw the Lewis dot symbols for nitrogen and for fluorine. I'm going to put nitrogen in the middle over here. Okay, and then I'm going to put fluorine surrounding the nitrogen. And why do I do this? Why do I put this in the middle, nitrogen? Because if you compare nitrogen and fluorine, nitrogen is more more electropositive. Okay, that one is more electronegative. So when you look in the lecture notes, I have given you that the more electropositive atom, in this case nitrogen, will be the central atom. Okay, so this is the central atom. And therefore, the more electronegative atom or element will be the terminal. Okay, so this is the terminal atom. Right, so that's how you identify who will be the central atom and who will be the terminal atom. So coming back to the Lewis dot symbol. Okay. Nitrogen, just now, if you go back here, you can see that nitrogen has 5 valence electrons and fluorine has 7 valence electron. So nitrogen, you can do 5. 1, 2, 3, 4, and 5. So equally distributed. And fluorine, you have 1, 2, 3, 4, 5, 6, 7. So it's going to be the same for all right. So after you have drawn all of the Lewis dot symbols correctly, you should be able to get another 1 mark for this. Okay. So next one, step 3, we need to draw the bonding pairs. Bonding pairs and lone pairs to construct the most plausible Lewis structure. So we've got nitrogen just now with that as the central atom, and then we have fluorine, like this. Okay. So when you look here, you have if I'm gonna go back here, you have that is your lone pairs. Okay, the one I have highlighted in yellow. Okay, those in yellow are lone pairs, and then those that I have highlighted in green, those are your unpaired electrons. Okay, so when you have unpaired with unpaired here, they will form a bonding pair, okay, which is a sigma bond. Okay, so that is a sigma bond right there. And then another unpaired combined together, you form another sigma bond. You have unpaired. With that unpaired, you form another sigma bond right over there. So this is the most plausible Lewis structure for NF3. So you can double check, because just now, if we go back to the first slide over here, we have identified that 26 valence electrons need to be involved in the construction of the most plausible Lewis structure. So we can double check. If you go back here, do we have 26? So let's have a look. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So we have indeed fulfilled the 24 valence electrons. So this is the most plausible Lewis structure for NF3. So what about if they want you to determine the formal charge? Okay, so when the question wants you to determine the formal charge, so you're going to draw the structure first, like this. Don't forget the lone pairs. Okay, so first I'm going to try to identify the formal charge of N at NF3. So the formula over here is valence electrons minus number of electrons at lone pair minus number of bonding pair. Okay, so when you look at your nitrogen has 5 valence electron minus number of electrons at lone pair. Nitrogen has 1 lone pair, therefore 2 electrons, minus number of bonding pair attached on the nitrogen. You have 3, so minus 3, therefore you have 0. So on your nitrogen over there, you have 0 formal charge. Okay, so formal charge of fluorine at NF3. The same formula, very simple formula. So the number of valence electron at each fluorine over there is 7. You have worked it out just now. Minus each fluorine has 3 lone pairs. So 3 lone pairs times 2, you have 6 electrons at lone pair. Minus each of the fluorine atom is attached to 1 bonding pair. So 1 bonding pair equals to 0. So each of the fluorine will have 0 formal charge. Okay, so you get 1 mark for this, 1 mark for that, and 1 mark for that one.